Hey, good evening. My name is Matt Batten. My Twitter handle is RedVuln, like red teaming and vulnerability research. And my talk is on .NET and Nvidia O days. So for .NET, obviously it's under Microsoft, and Nvidia's Nvidia for the GFE, and I'll go more in depth to that. So the first slide, of course, I have to go about myself. Who am I? And that's my wife and my best friend and all my animals. The animals are very important to me, and they're crazy. So like I said, my Twitter handle is redvon. My email, if you want to hit me up or ask me any questions. I enjoy having technical discussions or talking about whatever you like. And the company I currently work at is 6gen. I had 7 jobs in 2 years, and I was not happy. And I've been working at 6gen for almost 3 years now, and I don't plan on going anywhere else. And I'm surrounded by the brightest and some of the smartest people I've ever met, and I've never been the smartest person in a room. I'm very grateful that Ethan, our CEO, took a chance on me, and I'm still working here, and I love it. Um, so yeah, I'm a husband, red teamer, dog dad. I'm a Marine Corps vet. I was in signals intelligence, and I got out and I've been doing this, and I'm also a cat dad. So what we're going to be covering is the thought process, the tools, the actual examples, and closing thoughts. So the reason I put it out like this is because I want people to be able to watch this talk and then actually understand and reason, their way on how to actually find vulnerabilities. It's not when you watch this and by the end of it, you should realize, oh wow, that actually was not that hard. Like, I got paid for the .NET O-Day Prevest by Microsoft. Like that's real. And like the Nvidia one, they acknowledge it now. There's gonna be a link at the end. I got the CVE for that. And I think anyone could find it with a basic understanding. And after watching this and reading some other researchers, work, which I'll go into. So the thought process. There's so many different ways to do vulnerability research, right? There's code analysis, the static analysis, dynamic, and then there's behavioral, which I would say that I'm more right now behavioral analysis, where I do things and I watch weird stuff happening, and then I work backwards. Eventually, I get to the code analysis portion, but I start behavioral, which is not as technical, I would think, and say someone might disagree, but I'm trying to get more into driver ODay exploitation and everything. I'm really motivated at that right now because I really want some kernel driver stuff, because I want some ODay Prevest on Windows 10. It's like my big thing right now I'm going after, but that's more starting out static and then working the other way. Um, Great researchers who published their work got me to where I am now, such as James Horshaw, whom I really look up to. I'd probably like the next step in my dream goal would be sitting next to him for 2 weeks and just listen to him ramble or talk about how he gets to where he is. Where even I reread some of his blogs sometimes and I still only understand half. So I just need him to explain to me like I'm dumb. And then Matt Nelson, his research Enigma is what he goes by, and he has a great blog that I like reading, and it helps find some vulnerabilities as well. And my closing thought on like the thought process is like, why does this matter to a company or a government? Like why, like if you're watching this, you're not a vulnerability researcher, why should this matter to you? And I say to that like the SolarWinds issue. There's been so many issues, but that's just the most like one of the most recent where companies who were patched and up to date ended up being vulnerable, while companies who fell behind and did not patch properly on time ended up missing that. Obviously, there's other vulnerabilities when they don't patch on time, but every time you install new software, you update software, something's different, you end up introducing more things onto the system, into the network. And it can always be more vulnerabilities. There could always be more issues. And, or maybe it's more secure and completely locked down. But from what I've seen, whenever, new software is updated or new software is added or something's updated, there's been more issues than fixes normally. And then the tools that we're going to talk about, there's a lot of tools. There's more like nitty gritty, like IDA Pro and Ghidra and things like that. If you actually want to do some static analysis, like reverse engineering. But for this, and that's why I'm gonna say it's simple and it was fun and easy, is a just process monitor. So Windows internal suite tool. You can just see what's going on, and it shows the API calls and everything. And then James Forshall's tools, he actually made his own tools, so you know he's super legit. Like create symlink, like create hardlink, things like that. And I'll talk about that later on. You'll see it. And then having virtual machines, understanding how they work. Um, you know, having VMs, just be able to reboot them and keep your machine up helps a lot. If you test your own host machine at home, though, you'll probably end up finding a lot of vulnerabilities from things I'm going to talk about, from random software you've installed or downloaded. So here's Procmon. This is just what it looks like on your screen. I'm sure a lot of people have seen this, but a lot of people don't know that use it, which I find fascinating, that you can actually enable boot logging, where if you do enable boot logging and then you restart your computer while keeping Procmon open, it actually will show you everything that happened up to the point of your computer booting up, or like when you open up Procmon. So it's all those services and schedule, or all those services and tasks that started during the boot process, and you can go and see like what DLLs are getting called, what files are being created, things like that, and see if there's any way that you can bypass or elevate or do something interesting. Um, Obviously they're locking down on that and they're doing their best. But there's been some really funny ones at my previous talk, because the Nvidia one just got disclosed the other day. I couldn't talk about it, but I talked about a bypass UAC O'Day, which was just a DLL that was getting called a system. Um, I think it was a process create or load process, or yeah, I think it was process create, where it was just calling the DLL. It was like some API legacy DLL that ended up getting called. Um, but for this, you can reboot that. And obviously, the filters are some of the most important. So you'll see here that it has like reg open key, reg load key. These are some of the ones I look at. This isn't one I always use. This is just an example. You see process start. I think that's actually what was called, I believe, for that bypass UAC, not the process create. I believe it was process start. I can't remember. Maybe it might have been load image. But anyways, a bunch of filters you have. It does different things. Create file is harder now because of some mitigations put in place by Microsoft. We'll talk about that. I take out things like I try to take out like integrity level, like medium and low. You can take it out, or you can, like, I filtered in integrity is high, integrity is system include, because if I can get from if I can get a higher system from a medium integrity non-admin user, then that's a privilege escalation, right? If somebody's medium integrity with admin and I can get to high integrity without something popping up, then that's a bypass UAC. That's still that's still worth something. That's still interesting and valuable. So I see a lot of people just looking for a system. There's still a lot of ways around that. But these are just some examples of filters. There's more out there you can talk about or go into, but I'd say filters are probably one of the most important things to learn about Procmon and understanding from other people's work, methodology, getting it together. So this is the .NET local privilege escalation. So this actually affected like all of .NET, or I think most of the versions, like going back, or maybe it was an older one when I did it. Or it was actually the recent one, but I tested others going back and they all worked as well. And I found it really interesting where um, so Microsoft, they did not give me a CVE, but they paid me. I think it took them almost a year. Uh, it was really interesting. I emailed every now and then, but hey, they paid me eventually. Here I am. I'm happy I got it. I wish I got a CVE. I've emailed them 4 or 5 times. I never got a response about a CVE. I don't understand how they could just pay me and not give me a CVE, but I guess money's still nice, right? So I'm not going to complain too much, even though I'd really like a CVE, obviously. Anyways, so this is really important. So the path redirection mitigations, right? So they had, I actually took this from the Blue Hat talk a Microsoft employee gave. I believe it was a Microsoft employee. That was from his slides. I have the link at the end for his YouTube talk. But I thought it was an amazing talk, and it goes into like why mitigation is getting harder. Like when you do create a junction, right? They'll immediately mark it as a medium integrity level. So for services that fall like the high, it's saying that it's gonna screw you over because you're gonna hit medium. So now you can't just do basic junction to get that privs you want, or even the temp. See, when it was temp was a huge um, attack surface, right? And now due to mitigations Microsoft's putting in place, it's getting harder to stay logical, which is why, like, I mean, there's always logical vulnerabilities, and the people like, James Forshaw and others, they're always going to find ways around it, and I hope I find a few more, but that's why I'm looking more at drivers now, because I think it'll be really fun and a little bit easier. um, I say easier, we'll see, but I'm having a good time with it. So we're starting on the .NET. So the .NET LP, or local privilege escalation. It was really stupid. So I was sitting there and I was on my host machine and I was just running procmon. I just filtered like I showed you earlier, but a little bit better, where I did create file and a query open, stuff like that. And I did things running a system. I looked for name not found, and then I saw, because if something's not found, name not found, it's getting called a system and a user writable directory, right? C user, that's cool as the user. And app data, that's a user writable directory. So anybody can write to that directory, which means why is the DL being called a system in a directory that a user can write to? So that's the easy privs. But the issue is, how many computers are affected by this? Is this just my host machine? Is this some stupid software that no one else uses in the world? Why does this matter? So I saw that happen. So then I started working backwards through procmon, and I was wondering, like, okay, this is getting called, where is this getting called? So I click where the extensions.dll was. I see the SVC host, but then I just took off all filters and then I walked backwards and I found out it was .NET. And you can see there the actual create file .NET tools, right? That shows as well. Like, okay, it probably has something to do with .NET, even though it's not .NET, but oh, okay, like that obviously stands out. So then oh yeah, I should probably tell you, like, system integrity there, right? Path not found, name not found. Huh, it's really interesting. Name not found system.net. Okay. So then I go, what happens if I just drop this DLL, right? This is working backwards. This is not the most technical. And somebody could have found this from the other way if they actually dug into the code. But this is just, okay, WPTS extensions.dll, there it is. I drop it in there and I have complete access to that directory. Yep. See user app data local, and you'll see that was it full control. That's for, yeah, but you see desktop cool has full control, right? So some, but desktop cool, so that's, he was an admin when he installed it. So this is where it gets weird. So right now it's just a bypass UAC privs, because you go, okay, the person who can drop a file in there is an admin, and it was medium integrity and everything. Like, okay, you can bypass UAC if you're an admin, you drop in there, because it has to be the user who installed .NET, right? But you see the permissions there where it says desktop cool allow full control in the admin. So then when we get here, I know it's really small, but there's a load image. I know it's the blue, but there's a load image WPTS extensions.dll to SES, right? So that means as system it ran the DLL, which means you get, that's a bypass UAC ODay right there. But then you go, okay, well, is there any way this can actually be a privilege escalation? So then if you look here, I walked backwards through procmon, and then I realized this registry key was getting modified. And you can actually see that the way it's supposed to be is the path. So the environment variable, or it's the environment path, HK users.default environment. And the path here is supposed to be percent user profile percent app data local da 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 da. And then they made it path C user cool. So I was like, man, and then added on the .NET tool. So I was like, so when .NET is installed, it modifies that path. So when that service runs, it's checking that path. It's actually calling this path, and instead of going to percent user profile percent app data, it's going to the user who installed .NET, which you have to be an admin to install .NET, right? So right now it's still a bypass JC, but then what installs .NET? Like what does install it? Boom, it's MSI file. So it's the installer. So C1 is installer. That's where MSI files are when you're installing stuff, right? And it's it ends up being like, because of that, I realized in the registry key, it checks the registry key path and then it runs it. I clicked forward already. Can go back, but so for the .msi file, ends up when it's running, it runs as integrity, or it runs as the user you currently are. So, and then it modifies that registry key, right? The reg set value. So there's a .msi. It goes, okay, well, who can run the .msi file in C Windows installer, and that's why I did the iCackles, so you see that C Windows installer, everyone can execute them, right? Read, execute, X. And you can do iCackles, look at Microsoft Documents, and get a better understanding of that. So you go, okay, anyone can run the .msi file. So then there's ways you can search for which MSI file it was. I ended up just running them all, but you can actually do like fine string search for DLLs and things like that. There's a great talk. I gave his name at the end of a reference. I can't think of his name off the top of my head, but he wrote up a really good blog where he actually talked about my blog about this and his blog goes in such detail and his write-up's amazing on he's like .NET Spy and actually like went in and looked at the code level where I just did like behavioral analysis and figured it out from randomly clicking and being sporadic until it worked. I'll show his name at the end, but his write-up's amazing. If you go to the link, he explains it really in depth. But the gist is here. Okay, so now to ODay privilege escalation exploit because it goes you work backwards. Okay, a DLL is being called a system. Okay, it's being called a system. Where is it being called at? In the user rival directory. Okay, but only the user who I am, he's an admin, can write to that. So other users can't really write to it because it has to be this user specifically. Okay, well, why is it calling in this path? Oh, it's checking this registry key. What modifies the registry key? Oh, well, it's when .NET was installed. When .NET's installed, it's calling this .msi file, which modifies that registry key. So then, if whatever user runs the .msi file, it modifies that registry key with that user's name. So if it's a guest user or a basic user, then you just run that MSI file, then place a DLL in there, and then reboot the box, and then you have or restart the service or whatever, and then you have a system callback, and that's a ODay priv-es right there. I'm clapping in my head. That's a lot. I know it's kind of a lot, but then just going on to that, like something add on. This is a Nvidia, the GFE LP, right? So local privilege escalation, where they just gave me this the other day. I couldn't talk about it the last talk, but I'm glad I can talk about it this one where um, this actually, this can actually be an LPE. It can lead to code execution, and there's other things you can do with it. It's really simple. And when I show it, like this one's more simple than the .NET one. The .NET one's simple from like you didn't have to go in assembly, you didn't have to use .NET Spy, you didn't have to, like I clicked my way through and just banged my head on the wall until I figured it out, which is, like I'm getting more into assembly and like doing the drivers, but this is just showing like, man, like CVEs, like this is not that hard and it's not that crazy and anyone can do it. And I hope this motivates some people to go and do it. Where like, so for this one, um, okay, so that was the version of GeForce Experience I had, right? On my box. I need to upgrade my machine. I still had I still have a 970 to be honest. I definitely need to upgrade my graphics card. If you're watching Nvidia, you hear me. But anyways, no, it's nice enough that they acknowledged it and gave me the CVE. But what stands out here is that so the operation set rename information file, and I saw that it replaced one file to the other. And Matt Nelson, I think, actually has a great blog about it. And there's a few others, but I remember it, and I set my filters for stuff that other researchers have found. So this is really a collection of people who are smarter than me, and then I patch them together to make my own methodology, which I think a lot of people do, hopefully. But um, so here's the Procmani event information where it actually shows, okay, the operations is set rename information file, it says success, and then you see the path, C program data, NVIDIA, da da da, NV stream SVC, the file, okay, and it says file name old.log, right? So you see that if you look up and down, so SSAS current.log, SSAS old.log, so replace if exists true. So that's crazy. So in my head, I go, okay, if this is running, so it's running as system, which you'll see on the next slide. But if it's running a system, and I can just do a symlink on this where And like Microsoft, their mitigations are like create file, right? Injunctions and stuff like that. But like I don't know about the operation for set rename information file. So I figured I'm like, okay, well, I'll give this a shot on a symlink from James Forshall's tools. So if you look here, you'll see, okay, nvcontainer.exe, the set rename information file, there's PID, cool, and we see that the path is getting called successfully. And we're seeing the details, the replace if exists true for that file name again. Okay, so we know that the current .log replaces, or it replaces, the current .log is replaced by the old .log, and it runs this user, or runs the system in user idle directory, right? So the whole point here is you can see that the NVStream SVC, everyone has full access. So we all have full access to that. And then we see that everyone has full access to the NVIDIA Corporation directory. And the reason this matters is that to do a symlink, you have to have the empty directory. So I wondered, I was like, okay, if I can delete everything in nvstream.svc, if I can just delete that directory with everything in it, and then create a symlink to that file, will it actually work? So you can't, you can't just create a symlink to a directory that has files in it. The directory has to be empty. So you have to be able to have permissions to delete everything out of it. So there's some other interesting vulnerabilities that go into that. But we know that we have access because of these two. So NVStream SVC, full access. So we delete NVStream SVC. So then we have this. So then we go ahead and we create a symlink. And this is the syntax for that, right? So we're creating a symlink to the SAS current.log to whatever we want, which I did move.dll. I don't know why I did that. That's just what I ended up doing. And I create a symlink from SSAS current.log to move.dll. Why is that? I think in my head, okay, well, you know that it's writing that file. So during procmon, you know it's like if you restart the service or reboot the box, you know that for the example, like a POC or proof of concept, right? Like if this file is seen, so because the symlink's there, uh, the service goes, okay, this file is there, but instead of doing the old .log, it goes move.dll in system32. And that proves, because in a basic user context, it proves that I can create a file in system32, not as an admin and not a system. So I'm a medium integrity normal user, and because of that, I can well, not because of that, but because I'm a medium integrity user, and it followed my symlinks on that service, and it created a file in the system32 directory, then I know that I then have a privilege escalation, because a basic user shouldn't be able to write a DL in system32. And understanding integrity levels is huge here. Like you can see it says system. So like most users at home, if you do a who am I / all, you're going to be a medium integrity with administrative permission administrator, right? And then when you like right click CMD and you run as admin, you're then, if you do who am I / all, you're a high integrity administrator, right? And then you can kind of do whatever you want. You can get system easily with like PS exec, whatever you want. But a lot of people don't understand the integrity levels because they'll drop in a box and they're immediately, they'll be in high integrity on an op or system or whatever, and they especially like if they're just throwing internal blue or something like that around. But so that's the context here. So medium integrity, not an admin, just basic user like on a company network, and then you figure it out by creating the symlink, restarting the service. And again, like you could probably work this backwards instead of doing what I did. If someone actually like dove into the code and did some static analysis and then saw that the file was getting replaced by the other file, and then did iCackles or access checks or whatever, and then saw the permissions, they go okay. And there's that's more high speed low drag, because they're actually like, man, like I looked at the code and I saw this while I just ran procmon and watched what was happening and goofed around until I got something, which is it's kind of cool. But these are my references, and um, so Google Project Zero, symbolic link testing. He's amazing. I've already talked about it. Um, the Cisternal Suite, obviously, and oh, IT Man. That's the guy who I was talking about, where he had a great write up for escalation of privilege for .NET. And he actually goes in, like .NET Spy and actually like deep dives on that instead of like all the behavioral analysis that I did. And the YouTube channel, that's the one from Blue Hat, where he talks about the mitigations of cybersecurity, things like that. And the next two links are the actual Nvidia ones where they show the CVE and they grade it and the actual acknowledgments. Yeah, if you enjoyed this talk, and you'd like to know more, you can check out my references on the slide earlier. If you have any questions, feel free to hit me up. I'll answer any message as long as it's not something like really creepy. Um, but that's my Twitter and my email. And what I like to end this talk on is that companies need to be aware of this stuff when they implement new software in their company, and when they upgrade or update things, that it could open up more vulnerabilities, more possibilities, and like how dumb these logical vulnerabilities are, and like someone does not have to be a super hacker expert to get a basic understanding of, oh man, like a DL is being called a system in this user writable directory. That like there's ghost DLLs and everything like that, and they're super simple. They've been around a long time, just like unquoted service paths, right? Where just things aren't quoted out and there's spaces, and people replace them in their user writable directories. But like I said, there's a lot of great researchers who provided their information on the internet, and because of that, I wanted to give my support, hopefully, and this motivates some people and gets them started on their path of finding vulnerabilities and getting more excited and getting CVEs. And hopefully my next talk will be more on drivers and some sick Windows 10 LPEs, and eventually the next one will be RCEs. It's a dream. One can hope. I really hope you enjoyed this talk. Thank you for giving me the opportunity to speak. And again, feel free to reach out to me. All right, thanks.